Welcome to another video of this series about object-oriented programming. In this second Getting Started video, I'll perform an analysis of DrawingApp. In the introduction video, I gave a demonstration of this app, after which I formulated the question: suppose a customer asks you to develop a drawing app. Where to start? What is a step-by-step plan? And came with 3, optionally 4 points that you should address in a recursive manner. First of all, before starting to bang on your keyboard, it's a good idea to analyze the requirements of the customer, the result of which will serve as starting point of our implementation. Second, use the output of the analysis as input for the implementation, in our case Java. Then third, test the application, and we will do that in a console application. Ultimately, develop the GUI, so the graphical user interface app, using for instance JavaFX. Now, as for this OOP series, the goal is not to do the 4th point. This playlist is not about developing GUI apps. Instead, it's all about explaining object-oriented principles, and for that we don't need fancy GUI apps. Before we can actually draw rectangles and circles, we need to first perform an analysis, so as to come with clear definitions of what a rectangle is, what a circle is. So let's perform the analysis. The first thing is to listen carefully to what the customer wants us to develop. Suppose he summarizes the application as follows. So the story of the customer. Basically, what the program needs to do is to be able to draw rectangles and circles. When the user double clicks on a shape, a dialog pops up displaying the current properties of the shape plus its area and perimeter. What do we need in order to draw a shape? For the rectangle, an X and Y coordinate representing the drawing start position, so the top left point of the rectangle, with values which are 0 or greater than 0 with a maximum of 1000 pixels. Then 2 additional properties, height and width, having values lying between 10 and 500. Circle has similar properties for X and Y, with the same range of acceptable values between 0 and 1000, and they represent the drawing start position, so the top left coordinates of a rectangle that would surround the circle. And finally the radius with a value between 10 and 500. So suppose you have written all this down while listening to the customer. The next step is then to perform the analysis. Now, this is not an analysis course. The idea is just to show you the basic steps to perform in order to give you an idea of what an OO analysis might look like. So how do we analyze specifications? The first step is to look for nouns in the specification, because they might be used to define classes and properties of classes. I say might because not every noun should be taken into account. So let's indicate all the nouns and identify those that matter, all those relevant to what we need in order to define a rectangle and a circle. And it's not always easy, it's not exact science. Let's start with the first one, program. And with every noun you ask yourself, is that a relevant word? And actually the answer is no, not really. Program is what we write. What we are looking for are all those entities that are related to the things we draw. Obviously rectangle and circle, they form the heart of that specification, so definitely we're going to indicate those as useful nouns. User, ask yourself, is user a property of a rectangle or of a circle? The answer is known, so we're not going to select it. Shape, yes, but it's a little too vague because we're dealing with rectangles or circles. You can't really draw a shape. A shape is too vague, so no. Dialog box, again, ask yourself, is dialog box a property of a rectangle? Does dialog box help you to identify a rectangle or circle? And the answer is no. Then properties, well, that is what we're looking for, so not really. Area and perimeter, yes, but I'll say a bit more about these two later. Now, I don't want to go into every detail of this analysis, so let's move on a bit quicker and just identify all the nouns of interest to us. And I'll show them underlined. So we have rectangle, circle, area, perimeter, so the rectangle, we have the X and Y coordinates, we have the height, the width, and for the circle we have x and y as well, and the radius. The second step is to do something similar, but then with verbs, because they will help us to define methods or functions, things that will do something. Let's indicate all the verbs. Then identify from all the verbs we've just selected all the verbs that matter. Need? No, not really. Draw? Yes. But in the first stage, in a console application, we're going to print out its current state. So actually the display and the draw will be closely linked to each other. Double click no. Actually the only one is display. Again, it's not always easy to go after the necessary properties and methods. It's not exact science. So here we are. We have identified nouns, we have identified verbs, and I'm not going to consider area and perimeter as properties since they will be calculated. In other words, I'll consider them as two verbs, get area and get perimeter. The final step is to identify the data types for the properties and method return values. So rectangle, x, y, height and width are numbers and they must lie within a certain range. I'll define them as having data type int. The print method, which will display the current state of the object, will be a method that just executes some code. It's not going to calculate or return anything, so the return value will be void. Get area and get perimeter, on the other hand, they will return a value, and I will select a return value of float. Circle, very similar for x, y and radius, integers as well. The print void methods and the get area and get perimeter, they'll return float. Why do I use float and not double? Because in my under the hood videos, since ints and float take up 4 bytes, I can nicely align those properties. Whereas with a double, it's 8 bytes. That makes the animations a bit more difficult to manage. And that's it. This is our end result, which I used as starting point for the next step. Thank you for watching and see you in the next video.